In this presentation, the Simulink scheme, which is needed for all experiments for the single loop control, for the feed-forward compensation, and for the cascade control, will be developed. These are 3 block schemes for all configurations, which will help us in the design process. Let's open the Simulink library and let's open a Simulink model. This model is prepared by 3 parts that were already developed in former presentations. Namely, this is the PID controller, this is the model of the plant, of the process, and this is the part for the calculation of the criterion function. We have to connect these 3 parts according to these 3 block diagrams. For this, we need, of course, some additional components. We shall open the sources, because we shall need the constant. Then we shall open math operations. We shall need adding element, and we shall also need the gain. And of course, we shall also need some components for observations. So I will transfer one scope block in the window in which we built simulation scheme. So we shall start with this constant, which will realize the reference signal. This is this part in all 3 configurations. Then we need a summing point. This will be implemented with this block. So we can make this connection and this connection. Then, of course, we can start with this main control feedback. In this feedback, we shall put a gain. We must rotate this gain. And this is the feedback. We must have the negative feedback, so we have to change the sign of this block. In the connection between the main PID controller and the process, we need 2 summing points, so we can do it on this way, and we also need 1 gain. This will be the gain of the auxiliary controller. So we have to make this connection and this connection, this connection, and this connection. Now I can implement the auxiliary loop. I need another gain. This is auxiliary loop. I need another constant to implement the disturbance. And this is actually the influence of the disturbance. And then I will also include the feed-forward compensation. For the feed-forward compensation, I need another gain. and I will include feed-forward compensation with this structure. Now I will change the color of the auxiliary controller. I will select this color and I will define some parameters of blocks. This is the auxiliary controller, and this gain will be signed with the variable KPP. This is the feed-forward compensation. I will use the variable KPZ. This is the reference value. I will use the variable ref. The disturbance. This is variable Z. And I will also use these two parameters. This is actually the gain of auxiliary loop. This will be specified with this variable. And the gain of the main loop. We can increase this block so that the name can appear. We must also change these two signs. Instead of plus minus, the right configuration is in this case minus plus. We have to connect the part for the criterion evaluation. Here we have the control error, and so this is the right connection. And we can also connect the scope block. In order to have the possibility to start simulation from MATLAB, we must define the model outputs. Therefore, I shall open the things library, and the out block will be used for output definitions. The first output will be the control variable. The second output will be the process output. The third output will be the reference signal, and the fourth output will be the criterion function. So I must make now the proper connections. I can arbitrarily change the texts below the blocks. I can write here, for example, criterion. I can add some other texts. So this is the final scheme with the main controller with the auxiliary controller, with the model of the plant. This is the reference signal, this is the disturbance signal, and this is the part for criterion evaluation. We shall now test this scheme for the single loop control. That means that this auxiliary loop will be inactive and the disturbance compensation will be also excluded. The disturbance value will be 0 and the reference value will be 1. This is the MATLAB M file with all parameters which are needed for this scheme. So at the beginning I define the simulation time 100 minutes. The main loop is 1. This means that this loop is active. Auxiliary loop is 0. This loop is not active. Then we define KPP, the gain of the auxiliary controller is 1. KPZ is 0. And the reference value is 1 and the disturbance is 0. We use the parameters for the PID controller with these values. These are values which will be later obtained with optimization. So these are the values for proportional gain, for the integral time, and for the derivative time. With this command we start the simulation of this model and we obtain a vector of the moments of the independent variable. We obtain all states and we also obtain the matrix of outputs. With the plot statement we will plot actually the second output. The second output is the controlled variable and we will plot the third output. The third output is actually the reference signal. We have also here some other definitions from X label and Y label. We define axis and the title of the graph. So I can start the simulation. And these are the results. We can see that this is the reference signal and this is the controlled variable. So this response is already optimized. But we can also observe the process output in this scope block. So we can see the same signal as in the graph which was plotted with MATLAB command.